Beauty is in the details. This is actually the fourth axis to the CNC router that I'm assembling. And one of the things that came about as I'm trying to put things together, I'm looking at it, I'm like, why does some of the screws work and some of the screws don't work when I'm combining the linear rail, which is going to allow this tailstock to slide back and forth, onto the base plate that's going to be mounted on the machine. Okay, well, get rid of the spindle with the 3-jaw chuck. Let's get rid of the little extra jaws and the safety tool to change tools. What are we looking at here? So this rail has a little slot and it has these little inserts that go in there. And they basically grab it and they keep it all nicely together and go clamp. Now, what they've done in the design is they have countersunk holes. Wonderful. Bloop. We'll fit that in there. And we'll put another one in there, just to say the least. And then we come in with the little inserts. And we put the little inserts there, all nice and cute. And we just barely grab onto it. And we do the other thing to the little insert. It's nice and cute. And literally, we're barely grabbing onto it. And I said barely. So when I'm looking at this, so this is what I was doing the first time, and I'm going like, oh, okay, I'm just gonna slide it. And I try to slide it, and it's not quite working, so I open it up a little bit more, just so I can barely slide it. Nope, not quite working. Okay, just, and then that happens. It keeps falling off, and I'm going like, oh man, why doesn't this quite work? So is it because the chamfer's not deep enough? There's a coating on there. But in reality, I was like, wait a minute, if they're making this so tight on the tolerance, there's something that's called, you need 3 to 5 threads minimum to engage and to actually pull a load. In 3 threads, you're carrying about 75% of the load. The 4th thread carries 11, the 5th thread carries 9, and the next one carries 7. So those are what I call the oddballs. But I'm looking at then the threads here, and they said made enough threads. I'm like, oh, there's a little clean chamfer to break that edge. So all of these screws have the little clean chamfer. And then if you look at the inserts too, they have a little clean chamfer on it to do it. So by the time you include the first thread gone on the screw, the first thread gone on the insert effectively because it's there, and you try to put the tolerance analysis to it, they're gone. You don't really have enough to grip. And sometimes it grips, and now you're depending on the tolerance of your parts for it. So one of the things to do as a geek is, hey, let me do the mathematics on how long you actually need these screws to be minimum in order to account for the chamfer in the insert, the chamfer in the screw, and to engage this component. Most likely, I already went ahead and bought it, is these are 10 millimeters M5s, and I'm replacing it with the next one in stock, 12 millimeter. So that's it, 2 extra millimeters. But we're gonna prove it with math. This is what it looks like, this is what it is. It's the root cause analysis of what is taking place that's important here. That's it for the beauty is in the details for this episode. The rest of this is going to be, like the math is going to be included in the main page of the CNC router build.